Now, to compute the derivative of tangent x, first we'll write the tangent x as a quotient, because tangent x is actually a quotient, so you can write it as sine x over cosine x. And since this is a quotient, then we'll just use the quotient rule here. So we'll just apply the quotient rule. The quotient rule is this. Let me just remind you the quotient rule, which is if you're computing the derivative of, let's say the variable is x, if you're computing derivative of a quotient like this, then you will do derivative of top times the bottom minus derivative of the bottom times the top divided by square of the bottom. So basically we're just going to use this rule to compute the derivative of tangent. So we'll apply to the quotient rule to this. So therefore I will just do the derivative of, so we'll just say dy over dx. The derivative of top, derivative of sine x is cosine of x times the bottom is cosine x minus the derivative of the bottom, which is derivative of cosine x, and that's negative sine x, times the top, which is sine x, and that divided by square of the bottom. Now, when I multiply this 2, that's just going to be cosine squared x. And when I multiply this 2, that's just going to be negative sine squared. But you have another negative here, so that therefore that will turn into positive, and that divided by cosine squared x. But this is another identity. This is a unit circle identity which equals 1. So therefore we'll have 1 over cosine squared x. And 1 over cosine is another identity which is secant. So therefore this is secant squared x. So overall, now we know that the derivative of tangent x is secant squared x. And the things that we used here, let me just summarize it here. We used the derivative of sine x, and derivative of sine x equals cosine x. And also we used the derivative of cosine of x, which is negative sine x. Now we have the derivative of tangent x, which is secant squared x. So to prove that the derivative of this rational functions like tangent, cotangent, cosecant, secant, we don't really need to use the quotient rule all the time, but this is a way to prove it. So we'll just have to remember those when we practice with the derivative of trig functions.